Astronomers may have discovered the first planet outside of our galaxy. This is by Harvard-Smithsonian Center for Astrophysics. Signs of a planet transiting a star just outside of the Milky Way galaxy may have been detected for the first time. This intriguing result using NASA's Chandra X-ray Observatory opens up a new window to research for exoplanets at greater distances than ever before. The possible exoplanet candidate is located in the spiral galaxy Messier 51, or M51 for short, also called the Whirlpool galaxy because of its distinctive profile. Exoplanets are defined as planets outside of our solar system. Until now, astronomers have found all other known exoplanets and exoplanet candidates in the Milky Way galaxy, almost all of them less than about 3,000 light years from our Earth. An exoplanet in M51 would be about 28 million light years away, meaning it would be thousands of times farther away than those in our Milky Way galaxy. We're trying to open up a whole new arena for finding other worlds by searching for planet candidates at X-ray wavelengths, a strategy that makes it possible to discover them in other galaxies. This is what Roseanne DiStefano of the Center for Astrophysics, Harvard and Smithsonian CFA in Cambridge, Massachusetts says, and she led the study, which was published in Nature Astronomy just a few days ago. This new result, she said, is based on transits, events in which the passage of a planet in front of a star blocks some of the star's light and it produces characteristic dips in the light. Astronomers using both ground-based and space-based telescopes, like those on NASA's Kepler and TESS missions, searched for the dips in optical light, electromagnetic radiation humans can see, enabling the discovery of thousands of planets. I support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. DiStefano and colleagues instead searched for dips in the brightness of X-ray received from X-ray brightness binaries, and these luminous systems typically contain a neutron star or a black hole, and the black hole or neutron star pulling the gas from a closely orbiting companion star. The material near the neutron star or black hole becomes superheated and it glows in X-rays. So because the region of producing bright X-rays is small, a planet passing in front of it could block most or all of the X-rays, making the transit easier to spot because the X-rays can completely disappear. This could allow exoplanets to be detected at much greater distances than current optical light transit studies, which must be able to detect tiny decreases in light because the planet only blocks a tiny fraction of the star. The team used this method to detect the exoplanet candidate in a binary system called M51 ULS1. It's located in M51, and this binary system contains a black hole or neutron star orbiting a companion star with a mass of about 20 times the mass of our Sun. The X-ray transit they found using Chandra data lasted about 3 hours, during which the X-ray emission decreased to 0. And based on this and other information, the researchers estimate the exoplanet candidate in M51 ULS1 would be roughly the size of Saturn and orbit the neutron star or black hole at about twice the distance of Saturn from our Sun. While this is a tantalizing study, more data would be needed, of course, to verify the interpretation as an extragalactic exoplanet. One challenge is that the planet's candidate's large orbit means it will not cross in front of the binary partner again for about another 70 years, thwarting, of course, any attempts for confirming observation for decades to come. Unfortunately, to confirm what we're seeing, a planet would likely have to wait decades to see another transit, said co-author Nia Imara of the University of California, Santa Cruz, saying, and because of the uncertainties about how long it takes to orbit, we wouldn't know exactly when to look. Can the dimming have been caused by a cloud of gas or dust passing in front of the X-ray source? The researchers consider this to be an unlikely explanation, as the characteristics of the event observed in M51 ULS1 are not consistent with the passage of such a cloud. The model of a planet candidate is, however, consistent with the data. We know, they said, we're making an exciting and bold claim, so we expect that other astronomers will look at it very carefully. This is what co-author Julia Brenston of Princeton University in New Jersey said, saying, "We think we have a strong argument, and this process is how science works. If a planet exists in the system, it likely had a tumultuous history and a violent past. An exoplanet in the system would have had to survive a supernova explosion that created the neutron star or black hole. The future may also be dangerous. At some point, the companion star could also explode as a supernova and blast the planet once again with extremely high levels of radiation." Di Stefano and her colleagues looked for X-ray transits in 3 galaxies beyond the Milky Way galaxy, using both Chandra and the European Space Agency's XMM Newton telescope, and their research covered 55 systems in M51, 64 systems in Messier 101, the Pinwheel Galaxy, and 119 systems in Messier 104, the Sombrero Galaxy, resulting in the single exoplanet candidate described here. The authors will search the archives of both Chandra and XMM Newton for more exoplanet candidates in other galaxies. Substantial Chandra datasets are available for at least 20 galaxies, including some like M31 and M33 that are much closer than M51, allowing shorter transits to be detectable. And another interesting line of research is to search for X-ray transits in Milky Way X-ray sources to discover new nearby planets in unusual environments. This was from Harvard's Smithsonian Center of Astrophysics, and it's on phys.org, October 25th, 2021. Please leave your comments, and thank you for your support.